Hello, in this video we will talk about Bernoulli and binomial random variables. So suppose that you have a trial or an experiment whose outcome can be classified as either a success or as a failure. So this experiment has a binary results, success or failure, and we use x equals 1 if the outcome is a success. So here success maybe it is a coin or it is something happened, we call this is a success, just denoted with random number equals 1. And if it is not a success, then we use 0 for this random number. So such a random variable can be expressed as probability x equals 0 is 1 minus p, and the probability of x equals 1 is p. So here p is the probability, we say this is a constant long-term probability for a success in trial. So this kind of random variables called Bernoulli random variable. So Bernoulli random variable is a binary results random variable. And it has only one parameter called p. P is the probability for the success in each trial. So this probability is constant in each trial, and each trial is independent. So from this information, we can calculate the expected value or the mean value of Bernoulli random variable. So we use x equals all the possible values times their corresponding probability. So 1 times p equals 1 and plus 0 times p x equals 0. So the result is p. So we can see that the expectation of a Bernoulli random variable is the probability that the random variable equals 1. So the expectation of this random variable is also the success rate equals p. So now we turn to binomial random variable. So if we suppose that n independent trials and each trial represents a Bernoulli trial. So each trial has a success with a probability p and in a failure with probability 1 minus p. So there are n Bernoulli trials, right? And if we here use x represents the number of success. So here is the number of success, not the probability. So if we use x represents the number of success from these n Bernoulli trials, then x is said to be follow a binomial distribution, and we call x is a binomial random variable with the parameter np. So here n is n trials. We try n times of Bernoulli trial, and the p is same as the parameter in Bernoulli trial. This is the constant success rate in each trial. So it's very clear. There are two parameters n, p in binomial random variables. And the calculation of the probability for binomial random variables can be expressed as px equals I. So here I is less than or equal to x, right? Because we cannot have more success times than n trials. So I no more than n, right? Can be 0, can be 1, can be 2, can be n success times in n trials. And for each number of I, the success number is I, then we can use this form. So here ni with the parenthesis, these terms is a combination of ni, which means there are how many different ways of choosing i's I from total n. Because we just focus on the number of I success times. So for the n trials, these I success times can be put in different location in these n trials, right? Can be first, second, third. So there are how many times of different ways of I success times in n. So this is the combinations. And this combinations calculation is n factorial divided by I factorial times n minus I factorial. So factorial, for example, n factorial is 1 times 2 times 3 until n, the projection together. So this is the number of different groups of I objects that can be chosen from a set of n objects. And the next term is the p, and the quotes, the power is I, and times 1 minus p, the power is n minus I. So because there are I times success, so we have to multiplication with IP. And because here n minus I times failure, so we have to project 1 minus p with n minus I times, so their power number. So next we show an example using binomial random variables. So it is known that disks produced by a certain company will be defective with probability 0.01 independently of each other. So this is the success rate, about 1% for each disk in the long run. And the company sells the disks in a packages of 10 and offers a money-back guarantee that at most one of the 10 disks is defective. So which means, so because we pack 10 disks together, so of these 10 disks, if more than one of the 10 disks are defective, then we will pay the money back to the guarantee and return this package. So the question is, what proportion of packages is returned? And the second question is, if someone buys 3 such packages, so here packages represents 10 disks, right? And what is the probability that exactly one of them will be returned? So here one of them is the package, and the first question is focused on the disks inside of this package. So next we show the solutions. So X represents the number of defective disks in a package. So the package has 10 disks in total, right? Then if we assume that the customers always take advantage of the guarantee. So if the disks in a defective disks in a package is more than 1, so the customers can always get the guarantee. Then it follows that X is a binomial random variable with a parameter 10, 0.01. So here we just calculate the probability that X larger than 1. So here X means the defective disks inside one package, right? So Px larger than 1 equals 1 minus Px equals 0 and minus Px equals 1. So these two cases in these two cases, the defective number is not larger than 1, right? So we just 1 minus this 2 case probability and 1 minus combination change 0, and this is the success rate 0, and this is a 1 minus P10 and 10 1, and the defective rate times 1 power and 9 power for not defective. So the result is about 0.005. So this probability is about in the long run. In the long run, each package has about 0.1% probability will be returned. Yeah, so this is the long run. The large number, about 0.5% of the packages will have to be replaced, because this probability represents that the packages inside of each package, there are more than one disks are failed. So now we get this probability of the packages will be returned in the long run. And next, the question is, the customer, the buyer, purchased 3 packages. So 3 packages, and we want to know exactly one package is returned, right? So this is also a binomial random variable with n equals 3 and p is 0.005, right? So here we just use this form, binomial 3 way now. And this is the probability and with 1 in the power, and this is the 1 minus this probability with a 2 in power. So they're about 0.015. So about 1.5% in probability. So about 1 of 66, right? So about 1.5% of the probability that the customer will get exactly one package will be returned. Thanks for watching.